Hello everyone. Today we are going to solve problem longest subarray of ones after deleting one element. So in this problem, we will first explain the intuition behind this problem. Then we will derive an optimal algorithm for this problem. Then I will write a Java code and we will analyze its time complexity and space complexity. So without wasting any time, let's start. So let's start by understanding the problem first. So saying we are given a binary array nums and you should delete one element from it. Okay, return the size of the longest non-empty sub-array containing only ones in the resulting array. Okay, and to return 0 if there is no such element. Let's come here and understand the problem saying we are given a binary array where element is 0 and 1 only. So we are allowed to delete only one element and we have to return a sub-array with where a sub-array contain only one. So this is kind of problem where we have to return a sub-array of consecutive ones and we are allowed to delete one element from it. So if I take this example here, let's call here there is 0. Okay, so in this example, what will be the maximum length of sub-array? And keep in mind, in that sub-array only there are only ones in that subarray, no zeros. So in a make to return the longest subarray of ones, so what I can do, as I am allowed to delete one element, I choose to delete this 0 and now it's become this and this is the largest subarray I can return because this subarray only contain ones, so I can return. So in this case the output is 3. Let's analyze this problem here. What subarray I can return where is sub array, in sub array there are only one. So in that case if I take this sub array and if I delete this 0, if I take this, if I delete this 0, i I can return this sub array of length 3 because it is the largest I can see here. So I can return this after deleting 0, but let's not delete as of now. Choose another sub array. Instead of deleting this 0, take this 0 and delete this. So now I can return this subarray because when I delete this 0, my subarray become like this. So I can return this subarray and this subarray only contains 1. So it is a valid subarray I can return. So, if you understand the intuition till now, yeah, it is the same problem that we have solved in our last lecture of maximum consecutive ones. What's the difference between this? There we are given a integer k and the problem saying we are allowed to flip k zeros into ones, but here instead of flipping, what the problem saying, we can delete that number, otherwise requirement is still same. In that problem we have to return the maximum consecutive ones. Here also we have to return the maximum consecutive ones after deleting one uh, 0. So problem becomes same. Here our k is fixed, here k is 1. Every time I can for every problem my k is 1, I can only delete 1 0 and I have to return the maximum consecutive ones. So problem the same, and we have discussed this under sliding window. Why? Because we here we are given a k and the problem saying we can only delete 1 0. So valid window will be this. In this window is valid. If I take this 0 also in my window, it become invalid because problem giving us constraint that we can take delete only 1 0. If I choose to consider this whole sub array, in that case I have delete zeros and this is violate our rule. So in that case this is not a valid window. So how we solve this problem? We solve this using two pointer approach and sliding window use two pointer approach, and whenever valid window become invalid, we shrink our window from left until it become valid again. Take this example. I start from this L and R. I keep moving. When I reach, this is a valid window because till now I only contain 1 0 and I am allowed to take 1 because I know I will delete it later. So I can, my window contain 1 0 only. Once my window expand to this and window contain 2 0, in that case this become invalid. So what I have to do, I have to simply shrink my window. So from here, what I can do, I will shrink my window, and my L, if my L is here and R is here, if and my R is here, in that case, what I have to do, I have to simply shrink my window from here. For that, I have to move my L pointer till this, so that it do not contain this 0. So in that case, what I can do, I keep moving my L pointer until my uh, uh, window become valid. So in this window, my value my in my window contain only 1 0. So this is a valid window. I keep now I can expand my R. It is still valid because there is only 1 0. I can still move. So this is the whole intuition, and we have discussed it more clearly in our last lecture. For consecutive max consecutive ones, this is a similar idea. Yeah, in that case, we are given k, which can be vary according to question in uh, each question, but here our k is fixed every time. We can only delete 1 0. So we have understood. Let's come here and try to code it. So we know we need two pointer. One is L pointer. So I will take that L pointer. Now what I will do, I need a yeah, this is one pointer I need. I run a for loop where I run my R pointer. It will be R. It run from 0 to R less than nums dot length until length nums array gets end, and I keep increasing my R. Now what I will do, whenever I know here my k is fixed, so I can take that k here. K is 1. What this k indicating? This k indicating I am allowed uh, take 1 0 in my window. I can take 1 0 in window. So in this case, I consider this whole window, and at last I simply uh, reduce 1 from this length. Yeah, this will be simple idea. So whenever my R encounter a 0, what I will do, I simply decrease my k pointer. That's saying here my R encounter 0. In that case, I decrease k value by 1. Now my k becomes 0. When in future I encounter another 0, in that case, I will not consider that 0 because I have already considered 1 0 in my window. So in that case, what I will do, instead of I can shrink my window or simply consider this window. Yeah, this will be idea. So whenever my R encounter a R, whenever my R encounter a 0, I will reduce k by 1, and whenever my k become k become negative, what I will do simply, I instead of writing if, let's write while, because I keep until my k is invalid. What I will do, I keep shrinking my window, and whenever my nums L, whenever my left pointer find a 0, what it means, whenever my, let's correct it here, whenever my L pointer here, whenever my L pointer find a 0, I simply increase k by 1 because I am not considering that 0. If I come here, what I'm saying whenever my L encountering any 0, in that case, I increase k value because I am not going to take this 0 in my window. So I can simply increase my k so that I can, in future, I will take another 0. That's the idea. So whenever my L pointer taking encountering 0, in that case, I will increase k, and I keep moving, I keep shrinking my L until my K become valid again. My window become valid again, and at last I can simply track my max ones. How can I track my max ones? For that, math dot max, whatever the max, and my R minus L. Here I can add plus 1, but we know at last we have to reduce 1 from our max ones, because of what we are doing here, we are considering this whole array, and we know we can, in our max array there will be 1 0. So at last I have to decrease 1. So instead of decreasing here, I simply not add 1 here. It simply will be R minus L for simplicity, and at last I can simply return RETURN, max 1. Let's call it once, and here it would be max once. And we need a variable for that. So let's create a variable max once, and it starts from 0. Yeah, this is the whole idea. This is same as we solve in our max consecutive ones. Here we just fixed our k, otherwise whole algorithm is as it is. Hope this makes sense. Let's just submit, just run first to check. Here we forgot to add semicolon. Let's rerun again. Okay, we run too quickly. Again, there is a spelling mistake. It should be math like this. Math. Okay, let's rerun. Yeah, it's working now. Let's submit it as well. So hope you understand the idea. The idea is as it is, we just fixed our k. That case saying we can consider 1 0 in our sub array, and as this is our whole sub array, and we are considering 1 0 in that sub array. So we only need to return the number of ones in that sub array, but here there is 1 0, so we have to reduce one from our max ones. So simply instead of deleting, instead of returning like this max minus 1, here what I did, I simply r minus I did r minus l instead of writing r plus 1, because we know if we want the length of the sub array, we can do r minus l. We can say the difference tell us the length. We can write like this as well. Okay, it gets submitted as well, and we are getting a good time complexity as well. So let's come and analyze this time complexity and space complexity. So what's the time complexity here? So the time complexity is linear. Why? Because I'm running one for loop. Our for this our r is iterating over our terms once, and again here we are running a for loop for our L, and it also iterating over our N's, but they are not running simultaneously. Whenever my R reach whenever my R encounter another 0 or window become invalid, in that case I stop my R and start running my L. So they are not moving simultaneously. So in that case they are not nested. They are not working for nested. So in that case, one time complexity, one linear time complexity is for this, and one linear time complexity for this file. So on summing it, it give me the simply linear time complexity. So the time complexity is like this. So one for r n, and one for our inner while loop, and on adding it give me the only linear. And what is the space complexity? Here space complexity is constant, because I'm not taking any extra array or any collection. I am using this two variable, this three variable, which take constant space. So the space complexity is constant, and time complexity is linear for this problem, which is ideal. If you like the explanation, please consider to like my video and subscribe my channel. Thank you for watching.